Okay, ambiguous case of the sine rule will occur in questions that doesn't, number one, okay, it doesn't provide you with a diagram of triangles that they are asking. And number two, alright, for a very specific, definite case of an ambiguous case will occur when you have no diagram, and then they give you, alright, two sides, and they give you values of two sides, okay, values of two sides, and an angle opposite to one of the given sides. Okay, for example, the question describe and tell us the length of two sides, okay, can be side B and C, and it tells us the value of angle C. Okay, recall the naming convention in your sine rule in the previous page. Alright, angles opposite, sides opposite of angle. Okay, we name it with the same alphabet but in a small letter. So small and large letter will determine angles and sides. They are opposite one another. So if we look at this case, okay, we apply this. For example, for the scenario description below, alright, B and C are sides that are given, and angle C is the angle opposite of side C. Okay, so for triangles, for this diagram here, okay, let's look at AB1C first. Alright, for AB1C, okay, there's also another. Let's say the question gives us, alright, side B is some centimeters, and C is some centimeters. Okay, and B is longer than C. Okay, the length of B is longer than the length of C. Okay, and we also know this angle here. That means given in a question, means you can't change it, alright, because nobody changes values of a question that is given. So these are given, so these are fixed. So it describes a triangle that is like this. But it can also describe a triangle that is like your A, B to C, okay, with the length C being at this position, at B2. Okay, why is that so? Because, alright, if you look at this arc that is drawn, we call your topic on geometrical construction. This arc that is being drawn, okay, the distance from this arc to A, right, will always be length C. So any point along this arc, okay, from A will always be length C. Alright, but at awkward position like here or here, if we connect A to this point, okay, and then to our point C, right, it's not going to keep this value of my angle C that is given. Okay, because C is given, C is fixed, angle C is fixed, we can't change it. Okay, so only at two positions that it will give us this angle C that is being fixed in the question, so which is at this B2 and at this B1. Okay, at B2 and B1. So at these two positions, so if a question gives us this kind of information, okay, give us two lengths, and then after that it gives us one angle, and this angle is opposite this shorter length. Okay, B is longer than C. Alright, and for example, maybe B can be 15 cm and C can be 13 cm. Okay, so the question can give us maybe this angle here that is C, or some degrees that is opposite this 13 cm. So this situation will always, this kind of information there will always be ambiguity to what shape the triangle can take. Alright, it can either take this ACB1 or ACB2, because these three values that is given, 1, 2, 3, okay, they are unchanged, but yet we can form two different types of triangle with in this situation. Okay, if you do not understand, I would suggest you can replay this part and try to catch the idea again. Alright, so okay, let's look at this kind of situation. Let's say a question gives us the length of B, length of C, and then the angle big C. Okay, these are length. So now we understand, there are two triangles that can be formed. Okay, so the features of these two triangles, the angle AB1 C, okay, AB2. Alright, this angle ABC, there can be two possible values because the question is ambiguous. It doesn't fix the triangle at the correct shape. So there are two possible values, okay, of angle ABC. Alright, of angle ABC. Okay, two possible values. The question, keeping the length BC and the angle C, we can have two possible values, and also the length of length of C to B. Okay, we can have CB1 and also CB2. Okay, depending on which situation, that situation 1, situation 2, two different shape, two different possible triangles. So two possible values, okay, of the length CB. Alright, so two possible value of length ABC and two possible value of the length CB. So when you do your calculation, alright, you must be able to identify if the question is ambiguous. If it is ambiguous, okay, let's say question doesn't give you any diagram, it only will give you two lengths and one angle, and check. Alright, this angle correspond to the shorter side between the two lengths that's given. Okay, you have an ambiguous case. So if the question asks you to calculate angle ABC, you are supposed to identify, oh, this ambiguous case, I must take into account two possible angles, okay, values of angle. So you have to calculate two values of the angle, and for the length BC or CB, you have to calculate two sides. Alright, so this is a very, very definite case. The question gives you two lengths and one angle, and the angle is opposite of the shorter side between the two lengths. B is longer than C. Okay, now we look at other variation, and then we try to see if other cases of ambiguity will be present. Recall, questions give us length B and C, and also angle C. Okay, so some of you might think, what if I have this kind of situation? Alright, for this kind of a diagram, okay, definitely angle ABC will be perpendicular, right angle, and this will be angle C. That is given in the question. Okay, angle C that is given in the question. And it is mentioned just now, B is bigger than C, longer than C, and then this angle C here. Oh, so this one I also can have an ambiguous case. Alright, in this case, no. If in your process of calculation, okay, if you recall the previous figure 1, okay, there can be two possible values of your angle ABC. But in your calculation, for whatever value that the question gives, okay, if you calculate and you arrive at ABC equals to 90 degrees, okay, this triangle is fixed. There is no ambiguity. You can't swing out this length C, okay, onto different points here that will have the same distance of C from A, and then yet you form back to this angle C. You can't keep this angle that is given. Okay, you will have a smaller angle. Alright, remember this angle C is given in the question, so it has to keep its value, the size that is given in the question. You can't change it to different position and then after that give you a smaller or bigger value of C. So in this case, if your angle ABC is 90 degrees, alright, angle ABC is 90 degrees, there's no ambiguity. Okay, no ambiguity. Okay, so let me recap again. If you look at figure 1, okay, question gives us length B and C, gives us angle C. Angle C is opposite of the length C that is given, and length C is smaller than the length B. So in this case, we highly have a chance that it's an ambiguous case. There can be two triangle shapes that satisfy these 3, 1, 2, 3, 1, 2, 3, okay, values that the question gives us. Alright, so in our finding, if question asks we want to find angle ABC, there can be 2 possible values of AB. Okay, so if we in our calculation, if we find this, angle ABC we got 90 degrees, there cannot be any ambiguity. It is fixed. That is in this part, figure 2. Okay, so if we get 90, then okay, that's it. There cannot be any other possible triangles that is formed given these 3 values in the question. Okay, and let's look at figure 3. Okay, figure 3. Okay, for figure 3, the diagram is, I have to apologize, a little bit poorly drawn. What they are trying to illustrate here is that the value of the sides C and V that is given, right? The length of C is longer than the side B. Okay, same thing for angle C is given. Okay, so for this case, alright, angle C that is given, it matches with this side C that is given. They are opposite each other. But if side C is longer than B, okay, this triangle is also pretty much fixed, the shape. There cannot be any ambiguity. There cannot be more than one case of different triangle shapes fitting these values that is given. Okay, if C is longer than B. Alright. Okay, you can visualize a little bit if this C is being stretched out longer. Okay, if I make use of this arc also, okay, if I position my point B here, it is not going to keep this angle at the size of C that is given in the question. Alright, because if we connect it back, okay, this angle here will be bigger than what is being given. Okay, if we move along this arc, it is going to be bigger and bigger and bigger. If we move until this point, we may not even get a triangle. Okay, so there's only one fixed shape of triangle for this case of figure 3. Okay, if we look at figure 4, alright, there cannot be any triangle. Okay, how is that possible? It is extremely rare for you to encounter such situation as in given in figure 4. Okay, rare as in probably close to a chance of 0 when a question will give you something like this. Okay, like I mentioned before, question give you 2 sides, okay, sides B and C, okay, and the angle C, big C, which is opposite of your side C that is given. Okay, remember in figure 1 I mentioned how to tell that there is a chance of ambiguity. The length of B given is longer than C. Okay, length of B is longer than C. But in this case, okay, you can't even form a triangle because the length of C is so short. You can't form a triangle that keep this value of C that the question gives. Okay. So if I draw it this way, the length of C is too short. Alright, it is if I connect it to the length to this point C, alright, it is not going to form the size of the angle given in the question. Okay, you can see here the angle is so small. Okay, what if I move along this this arc, okay, which give me the distance of C from A if I move along. Okay, if I move to here, it's also going to give me a smaller angle. If I move here, it's also not going to give me angle of C that is given in the question. So in this case, there is no triangle. Okay, there's no triangle. That means if the question describe, I have a triangle length BC and I'll give you one angle value, give you 2 sides and one angle. You can't even form a triangle. So in this case, there will be severe problem with the question. Okay, but then on a safe side, how do we check? How do we differentiate between figure 4 and figure 1? Given that the conditions are similar, you have B given longer than C and then the angle of C opposite. Okay, one way is to find out this length here. How to find out this length? Alright, so this length, what we can do is using our Tokaso. Okay, using our Tokaso, we will get B sine of C. Okay.